Okay, so we're going to learn how to make inferences about the simple linear regression slope. I see some data here, something about schools. There's 10 schools, annual tuition, so some money, annual tuition, so how much the schools cost per year, and percentage with job offered, and some numbers. So let's read what the instruction says. If you pay more in tuition to go to a top business school, will it necessarily result in a higher probability of a job offered at graduation? Okay, so I see what the question here is, if you pay more, does it really mean that you're going to have better job offers or more job offers than if you pay less? Let Y equal be the percentage of graduates with job offers and X be the tuition cost. So we see the information here. Then fit the simple linear model. EY is beta 0 plus beta 1 X. This is pretty much like the formula we have been looking at as Y hat is equal to beta 0 plus beta 1 times X. We've seen that one. And then we're going to ask, is there sufficient evidence at alpha at 0.10 of a positive linear regression between y and x? So we're going to see this. Now, given the following no alternative hypotheses, so we're saying that our beta 1 is 0, and then alternate is beta 1 is greater than 0. Now, if beta 1 was equal to 0, wouldn't that cancel this? So we're saying that it does not. It does not have an effect, but that's why we're checking. What if our beta is more than 0? For testing whether there exists a positive linear regression between y and x. Okay, so we have to answer what's the t-value, the test statistic, and our p-value. Now, to be honest, in order for you to be able to figure this out, there's a few values you need. So I'm going to write here at the side. You need your sum of x times y. Your sum of the squares of x times x. You're going to need the sum of the squares of x times y. You're going to need your beta 1. You're going to need sum of the squares of the error. You're going to need your standard error. You're going to need your standard error of the least square slope. And then we're going to be able to find our t statistics. Okay, so what do we need? Let me remind you of formula. We have seen some of this before. For my sum of the squares of x, y, I need my sigma, my sum of x times y minus the sum of x times the sum of y divided by n. I'm going to alternate my formulas between red and blue so we don't get confused. For my sum of the squares of xx, I need my sigma, my sum of x times x minus sigma of x times the sigma of x divided by n. For my sum of the squares of yy, I meant here yy. My sum of the squares of y, I need my sigma of y times y minus sigma of y times the sigma of y divided by n. I know we saw this before. This is something that you guys should be a little familiar with. My beta 1 is going to be the sum of the squares of xy divided by the sum of the squares of xx. Like I said, I'm alternating between red and blue so we don't get confused. My sum of the squares of my error is going to be my sum of the squares of yy Remember, that's this one. Sum of the squares y minus beta 1 times sum of the squares of xy. Now my standard error is going to be a square root. Inside the square root, I'm going to have a fraction. Going to be my sum of the squares of my error divided by, now here at the bottom, I'm going to have n minus 2. Basically my degrees of freedom. My standard error, the least square slope, or SB1, is going to be my little s divided by, and at the bottom, I'm going to have the square root of the sum of the squares of xx. So now, when I go to Excel, because I'm going to go to Excel, when I go to Excel, I'm going to say, according to our formula, this is what I mean. Okay. So now in Excel, I put in my X, my Y values from the table. Right? I'm not going to copy them. I copy them ahead. So notice how I label my X on the top, my Y there. So now, things that I need my X times X. I need my X times Y. And I'm going to need my Y times Y. So for my X times X, let me go equals X times, and then I click on the X again. Gives me a big number, right? X values are big, so it's fine. For my X times Y, I'm going to go equals the value of X times the value of Y. For my Y, I need equals Y times Y. Then I'm going to highlight these. So on my left click, I highlight what I want. Then there's a little point here at the bottom. I'm going to click it, left click, hold it, drag it down, and it complete my list there. I'm going to click on one point random. So yeah, it's X times X, which is what I wanted. Good. I'm going to click here on the X, Y, it's a random value just to check. Yeah, it is correct, X times Y. And then on my Y squared, I'm going to click on this one. Yeah, it is Y times Y. So good. Now here at the bottom, I'm going to go equals. I'm going to do the sum of each column. So I'm going to go sum, open parentheses, and let me highlight my X column. Close it. So I just added all the X's. I click on this, at this little point, I'm gonna left click, hold it, I'm gonna drag it. There's a 0 here, I'm gonna erase it because there's nothing there. Now this number here, let me explain what the E means. This is basically looking at 1.4527. Now the E, when there's an E, that means it's written in scientific notation. So I have to go times 10 to the, then I see my exponent here is a positive 10. Oops. And there. That's what that means. When there's an E, it means it's written in scientific notation. It's a very big number. And yeah, because the X values were big. Okay. So now you know what those means. Okay. Now let's get to my list, what I need. Okay, so I have the formulas. I give you the formula. I need sum of the squares of x, y. Press enter. It autocorrects, so I go back. Sum of the squares of x, y. I like to label things. I'm also going to find the sum of the squares of x, x. I'm going to find the sum of the squares of y, y. I'm going to find my beta 1. I'm going to find my sum of the squares of the error. I'm gonna find S, that means standard error. I'm gonna find SB1, which basically the standard error of the least squares. I'm gonna leave a space, and I'm gonna have a T. That's gonna be my T statistics, and then I'm gonna find a P dash value. You can just leave it as P if you want. Okay, the T and the P value, that's what I've been asked for. Okay. I gave you guys the formula, so I'm gonna go for my sum of the squares of xy equals. I have to go the sum sigma xy. So xy is right here. So sigma is this on the bottom. Sigma xy minus sigma x times sigma y divided by n. There's 10 numbers, right? The data has 10, so my n is 10. So that's my sum of the squares of xy. For sum of the squares of xx, I have to go equals sigma x squared. So sigma xx, so that's this one, minus sigma x times sigma x divided by 10. Because it was divided by n. For my sum of the squares of y, I have to go equals the sum of y squared, or the sum of y minus sigma y times sigma y divided by 10. For my beta 1, I have to go equals sum of the squares of xy, so this one, divided by sum of the squares of xx, this one. Okay, so there's my beta 1. My sum of the squares of the error, I have to go equal sum of the squares of y, which is this number, minus beta 1 times the sum of the squares of xy. My standard error, it's a square root, so I have to go equal square root in here. It is going to be SQRT, open parentheses. So that's how we write square root. So in here, I have to go SSE. So this numbered divided by, remember how I told you it was n minus 2? Since n is 10, so I'm going to write 8. So there's my standard error of least squares. I mean, my standard error is SSE divided by n minus 2 inside the square root, okay? For my standard error of least squares, so my SB1, I'm going to go equals, have to go S divided by square root. So SQRT, open parentheses. And then here have to go my sum of the squares of XX, close parentheses. Okay, so I found all of these. Now my T value. Let me come back to our notes here. I found all of these. My T value, my test statistic. I'm going to give you guys a formula for this. My test statistic is my beta 1 divided by my standard error of least squares slope. So we call this my beta 1 divided by SB1. And I'm going to round my answer to 2 decimal places. Okay. So for my T value, I'm going to go equals beta 1, which is this one, divided by my SB1. I'm going to round this to 2 decimal places. I'm going to call this 0.77. Now my p-value, I'm gonna go to Excel and I'm gonna say I'm using the t distribution. So I tell it TDIST. Obviously we press equal to begin with. So t distribution. I'm gonna open my parentheses and I'm gonna use my t value, which we know is 0.77. This is comma, my degrees of freedom, which is n minus 2. In our case, is 8. And then the tails, it's either 1 or 2. My case, I'm going to use 1 tail. Sometimes we use 2. How do I know? From my alternate hypotheses. That's why I gave you guys the hypothesis earlier. If I use the inequality sign, okay, see my alternate hypotheses, then it is 1 tail probability. If I use not equal to, then it's a 2 tail distribution. So in this case, because the inequality sign, 1 tail distribution. All right, so this is what I'm going to type in. So, okay, let me come back to Excel. So I'm going to go equals TDIST for T distribution, open parentheses, my T value. So I click on it, comma, my degrees of freedom are 8. Because there's 10 values, 10 minus 2 is 8, comma, tails, 1 tail distribution or 2 tail distribution. In my case, I do 1 tail distribution, close parentheses, press entered. I'm going to round this to 4 decimal places. So 0.2320, because the 6 pushes the 9 and the 9. So 0.2320. Good. Found our test statistic and our p-value. Now make the appropriate conclusion that alpha is greater than 0. Now here, I actually answer this. I'm not going to ask you guys to come up with a conclusion. I see my alpha is smaller than my p-value. So that way I'm not going to reject the null hypothesis. Notice how I typed in for our notes. For our notes, I typed in the conclusion. On your homework, I'm not going to do it. For the notes, I type in the conclusion. We're not going to reject the null hypothesis, right? Alpha is smaller than my p-value. I think we did enough conclusions, because we're not rejecting the null hypothesis. We say there's not sufficient evidence that there exists a positive linear regression between y and x. Again, for your homework, I'm just going to ask you for the test statistic and the p-value. I'm not going to ask you for the conclusion. I did it here in the notes, but notice I gave you the conclusion already. Again, I think we did enough. I'm not going to do any more. Okay, that's basically how we do these questions.